Okay, welcome to the solution video for practical 6. Okay, let's get right into it. So, practical exercise 1. Write a program that gets an initial amount invested by a person, a top-up amount that gets paid at the end of every period, a percentage increase for each period, and the number of periods that the money will stay in this investment. Once the user has input these values, the user clicks the calculate button. The program should return a user-friendly message stating the user inputs as well as the final value of the investment after a given period. Okay, so we got to get at least 4 inputs here, which is the amount, top up, the amount invested, the percentage, and how long it stays in. So I'm going to use 2 text boxes and 2 numeric up downs. I'm going to use 2 text boxes and numeric up downs. For those 4 inputs, I'm going to need to label each of those so that the user knows what they are. And I'm going to need a button to calculate. So there are my controls. I'm going to go ahead and quickly name these. I'll fast forward the video. So I'm just going to name and change the text of each of these. Okay, so I've managed to rename all my stuff and put the appropriate text for each of the controls. I can except I see here that I switched the name and the text around on this one, so let me just fix that up. And I've got my button over here. Let me make this look all a bit neater. So now I can check that all of my controls have actually got a name. Everything does except the form, so I'm going to just go change the name of the form and the text. So I'm going to call it investment and FRM invest. So now we can get to the coding. So all of the coding is going to happen on the buttons click event handler, and we need to take a look at what needs to happen. So first we're going to need a bunch of variables to store the user's input. So we're going to use, I'm going to use, I think doubles and ints, a combination thereof. So int for period, double for %, initial, and top up. I reckon that should be fine. And then also a double for final value, which will be the final value of the investment. Now we need to get each of the values that the user's input. So let's go period is equal to txt period, it's a nud period, dot value. We're going to need to convert this value to an integer, so let's go ahead and convert dot to int. We need the %, so percent is equal to nud percent dot value, and then yet again we are going to have to convert that, so I'm just going to go ahead and copy this and paste it over there. What's next? The initial value. Initial is going to be equal, let me just go ahead and convert dot to double. Why am I converting to an int here? This needs to be dot to double. What am I converting to double? The text box, text txt initial dot text, and then the last one that the user inputs is top up, which will be equal to that. Convert dot to double. Again, the txt top up dot text. Okay, so we've got all the user values. We've stored them in our variables that we've created over here. Now we can go ahead and work out. No, before we work out, let's do this user-friendly message and the output part. So it says a message, so let's use a message box dot show. What are we going to show? We'll say your initial investment of, and then we'll have their initial here. Let's create a new line. Your initial investment of, will be worth, and then we're gonna go add the final value, what it's actually gonna be worth. Let's give this value of 0 for now, just to take away that error. /n, it'll be what with rand. This will after, let's just say after the period, after that many periods, periods at an interest rate of, and then just go percent, we called it. Add the percentage sign here. Let's see somewhat what that looks like. So initial value of, let's call it 100, 10 for the top up, 10 for that, 2 for that. Okay, so no calculation is done yet, but our message box looks decent. So now we can go ahead and do the calculation. So what do we need to work out? We need to work out the value of final value over here. And the final value will be equal to a certain percentage of the initial value after every month with an additional top up every month. So to work out what it is after every month, we need to know how many periods it's going to stay in there. We have that over here. For each period that it stays in there, we're going to do a bunch of calculations. So this is where your repetition comes in. So for repetition, we're going to use, in this instance, a while loop. In this while loop, we're going to say while. Again, one more thing we need is a counter, which can be set to 0. We're going to increase the counter continually each time the while loop runs. So we're going to say while counter is less than period, yard. And to prevent our while loop from being infinite, we're going to increase counter every time. So every period something needs to happen. In the first instance, we're going to say final value is equal to percent of final, because we want it to be compounded. If I said initial over here, it would be simple interest. We want compound interest. So let me just brackets that up, plus the final value. So now we've determined the percentage of the final value plus the final value. Percent is not actually going to be a percent yet, so let me just go ahead and say divided by 100 to turn it into a percentage. Or, because I'm going to use that percentage over here in the message box, I want it to be a full value, so I'm going to divide it by over here. So we said x% of final value plus final value. Thereafter we need to add the top up. But now final value doesn't have an initial value. Well, it does, it's 0, but our final value on month 0, so before the money has stayed in for a full month, will just be the initial value, what the user has input. So we're going to say final value is equal to initial. Let's go ahead and test this. 10%. Okay, your initial investment of 100 Rand will be worth 142 Rand after 2 periods at an interest rate of 10%. Okay, so I've worked with these numbers before. I know that's correct, but we can just check that it does actually change digits. Let's say 15% for 55. That's some maths. Okay, cool. Here we go. So practical one done. It wasn't that much code, but in order to do the repetition, we had to figure out the while loop with the counter and do the math for each period. So just make sure you know how a while loop works and why we've used the while loop here. Just to reiterate, we used the while loop to loop for every single period that the money stays in the investment account. And for every period that it's in that investment account, something's going to happen to that money. In our instance, it's going to increase by the percentage of itself. So if it's 10% of itself, it's going to increase by 10%. And then it's additionally going to increase by the top up, so what the user is going to pay in additionally every month. All in all, a pretty short practical, but with some new concepts there, like the while loop. So let's move on to practical number 2. Prac 6 exe2 solution vid. Here we go. Hey, what are we doing in practical 2? Practical 2, we need to draw a bunch of patterns. Okay, so to do this, we're gonna need, I'm gonna make 2 buttons, one for each pattern, and we're gonna need to note that you should be able to input how many rows and columns, so we're gonna have 2 text boxes for rows and columns, or numeric up downs. I'm gonna make them numeric up downs for rows and columns, and then another numeric up down for iterations. Yeah, I'm gonna go ahead and fast forward the video while I add all of those things to the form. Okay, I've added all my controls, I've changed all the appropriate properties except one. So I'm going to use a text box to draw the patterns, and there's a new property that I'm using to make sure that I can write on multiple lines, and that's the multi-line property. If we just change that to true from false, we'll be able to make it large like that. So now we can draw, looks a lot like a list box, but it's not a list box. We can draw on multiple lines, and we can make the text box as large vertically as we want. So let's begin with the pattern A. So what do we have here? The program creates 2 types of pattern, pattern A and B. The user should be able to input how many rows and columns they want to create. Okay, so when button A is clicked, we're gonna, first things first, we're gonna clear the text box. So .text is equal to nothing, just in case that there's something in the text box from a previous time we drew a pattern. Next, we're going to need some variables. We're going to need int rows and columns. We're going to set those variables to what the user input, which was nud rows dot value, and we're going to have to convert those to integers. So convert dot to int. There we go. Sweet. And then we're going to have to do the same for columns. So nud columns dot value convert to int. Okay, happiness. Thereafter, we're going to have to, what are we going to have to do? We're going to have to begin with while loops. Okay, so this is going to require a nested while loop, because we're going to need to draw each row individually. So what's going to happen is we're going to check if there's a row 1. If there's a row 1, we're going to check if, when I use the word if, I do mean that we're going to use a while loop. We're not going to use an if statement, because remember, what goes inside these brackets over here, these 2 brackets, is a conditional statement. So it checks whether something is true or false. So if something is true, it runs the while loop. If it's false, it stops running that while loop. So we're going to check if there is a row over here. If there is a row, we're going to check if there is a column over here in this one. So check if there's a row, if there is a column. If there are both of those things, we're then going to draw a star. If there's another column, we're going to draw another star, and so on and so on and so on. For ease sake, we're going to have 2 counters as well. Counter 1, which is equal to 0, as well as counter 2, which is equal to counter 2, which is equal to 0. Okay, so while starting off with rows is greater than counter 1, we'll say, and while columns is greater than counter 2. We're going to then have to prevent it from being infinite, so we're going to increase counter 1 and increase counter 2 over here. There we go. So we got our loops somewhat set out for now. Now we need to do some drawing. So what this checks in this part, in this while loop, is it checks if there is a row. If there is a row, we then check if there is a column. Doesn't matter how many there are, we just check if there is one. If there is a row with no columns, it means that there's no star, because you can't have a star without in a position without having a column. It needs both a row and a column to be able to be drawn. So we check if there's a row, and if there's a column, there is one, so we're going to go ahead and draw a star. So I've said, oh whoops, let me just, txt pattern is equal to star. This isn't going to work because what it's going to do is every time that there is a column in a row, it's just going to set one star to be drawn. Instead, I'm going to say plus equals to. Let me show you what the difference is. So this is with just the equal sign. 10 rows by 10 columns, pattern A, just draws one star. If, on the other hand, I got plus equals, and I got 10 rows and 10 columns, it then draws stars on top of the existing ones. Obviously, it's not perfect to our pattern just yet, but you see the difference that a plus equals 2 makes. So that's an important thing to try and remember. What this plus equals 2 does basically is the same as text is equal, dot text is equal to dot text plus a star. These two lines, this one and this one, are basically the same. Well, they aren't basically the same, they are the exact same thing. We're setting the text to equal the current text plus a new star. We're setting the text to equal a current text plus a new star. So there we go. Now, as we saw when I was showing you the difference there, what happens at the moment is it just draws 10 stars. Let's run it again just to show that. 2 by 2 just draws 2 stars. It basically only draws one row so far. Why that is, let's go ahead and just use the debugger. Another thing that you guys were taught during class, we added a debugger, a breakpoint over here by going right click, breakpoint, insert breakpoint. We then run the program, we input 2 and 2, and we click pattern A. It pauses the program for us over here, and now we can see the value of all our variables step by step. So while rows is greater than counter 1, rows is 2 and counter 1 is 0, so it is greater, it's going to run that. We are now inside this while loop. Then we're checking columns is greater than counter 2, columns is 2, counter 2 is 0, it's true, so we're going to go inside this while loop. We then write a star into that text box, done. We then increase counter 2 by 1, so counter 2 is 0, counter 2 is now 1. It then goes back to this while loop over here, not this first one. It again checks is columns greater than counter 2, columns is 2, counter 2 is 1, it is greater than, draws another star, adds 1 to counter 2, which is now equal to 2, and checks again is columns greater than counter 2, columns is 2, counter 2 is 2, so it's not greater than, so it's going to not execute that while loop. Then adds 1 to counter 1. It then checks again, is rows greater than counter 1, rows is 2, counter 1 is 1, it is, so it runs there. So why doesn't it draw extra lines? Well, if we take a look at our variables, we've gone onto a new row, as we wanted to, we've drawn this first row, but we now want to draw the second row. We've identified that there is a second row, so it's reading that correctly, but it's not drawing us stars. So let's check why. If we look over here, columns is equal to 2, which it is, there's 2 columns, and counter 2 is also equal to 2. So because we drew 2 stars in the first one, we increased counter 2 twice over. So what we need to do is we reset counter 2 to its initial value, which is 0, and then rerun the program. So let's go ahead and try to do that. So we're going to, after it is run once, so after it is basically drawn one row, we're going to reset the amount of columns that there are through counter 2 to be equal to 0. It's not going to be 100%, but I'll show you why soon. So if we try again, pattern A, 2 by 2, it's drawn us 4 stars. So that's a bit better, but now they're all on one line. We've got the amount of stars that we needed to have, but they're all on one line. So let's go ahead and look why. I can see here that at no stage do we implement a new line. So I gotta look, where should a new line be implemented? It's after every new row. So this is one row happening. So this while loop determines rows. This one determines columns. So after one column has been written, we want to write a new row. So we go txt pattern.text is plus equals to again, not equals to, and we're going to set it to \r\n, and let's go ahead and test this. So we went 2 by 2. There we go, 2 by 2. Let's try with a bigger number. Let's go 9 by 12, 120. It's gonna take a while. That looks messy. Let's rather go 20. 9 by 20, 1 by 20, and 20 by 1. Oh yeah, there we go. 20 rows, 1 column. All is looking well. Now, that's pattern A sorted. Now we can go on to pattern B. So pattern A was a bit easier. Pattern B is slightly more complex. Again, we're going to need counters. We're going to go int counter 1 is equal to 0. Counter 2 is equal to 0 as well. And we're going to go iterations, the user input. We're going to set iterations to be equal to nud iterations dot value. Value, there we go. We got to convert to an integer and done. So now, wait, there's one more thing I gotta do here is I gotta just make sure I reset the text every time, so it doesn't add on to the existing stuff. So now we've gotten our user inputs, which in this case is just one thing, and we have gotten our 2 counters. So I already know what the code has to look like. I've worked it all out and everything before and long ago, so I don't need to go ahead and draw it on paper or anything like that to try to figure it out. But what I would suggest you guys do in something that's a bit more complicated is get a piece of paper out and just try test with while loops when it needs to start counting, what it needs to count up to, and when it needs to stop counting. So in this case, for instance, I can see that each row has the number of digits in it. So it ends on the last number of digits. So in row 1, we have 1 digit and it stops with 1. In row 2, we have 2 digits and it stops with 2. In row 3, we have 3 digits, it stops with 3. In row 4, we have 4 digits, so it stops with 4. So there's a slight pattern that I've identified. So I know already that I'm going to need 2 while loops, I'm going to need 3 counters, and I know what limitations those while loops are going to have. So i.e. when those while loops will need to stop counting and when they will need to be reset so that they can continue counting. So let's just draw the skeleton of these while loops. So here's my 2 while loop areas. What I want to check in the first one? Well, I'm going to use my first counter, counter 1, which is set to 0. And I'm going to check whether that is, because it's 0, it can only be less than something. So because it's 0, it can't be less than counter 2, it's going to be less than, whether it is less than iterations. If it is less than iterations, I'm going to run something else. Let me just go ahead and prevent that from being an infinite loop, so counter 1 plus plus. If it is less than iterations, what are we going to do? We need to check whether we need to, if we have actual numbers to draw and how far we're supposed to draw them. And what I mean by how far is, what is the maximum number that we got to go up to? So we've checked that there is 1 row. Now we need to check how far that 1 row needs to count up until. So it needs to count up until its current row value, if that makes sense. So we're on row 1, so we need to draw up until row 1. So we're going to use our second counter. I'm going to check while that is less than or equal to our first counter. Why our first, I can't spell counter. Why our first counter? Because our first counter looks at the rows. It determines how many rows there are and what row we're currently on. it's also, counter 1 is also limited by the amount of iterations there are. So counter 1 can never exceed the amount of iterations there are, else this while loop won't run, meaning this while loop can never run. So, for instance, if iterations was set to 2, counter 1 this is 0, so this while loop over here will run twice. Each time that that while loop is run, we're going to run check for this one. Counter 2 is set to be 0, and it needs to run while it is less than or equal to counter 1. Because we only increase counter 1 over here, it is indeed less than counter 1, so it's going to run once on the first time. We need to prevent it from being infinite, so how do we do that? Counter 2 plus plus. Once we've run it once, what do we need to do? We need to draw something to the text box. txt patterns plus equals. What are we going to draw? Well, we're going to go ahead and draw. We can't draw iterations because that's just the last number that the user wants to input. And we can't draw counters because that's rows rather than the values of each row. So we're going to draw counter 2. Counter 2 is set to 0. We want it to be 1. So we're going to just go ahead and add 1 to counter 2. Once this while loop finishes, similar to when this while loop finishes, we need to add a new line. So I'm just going to copy this code over here and paste it over there. Now we've added a new line. That means we've gone on to row number 2. So we need to reset. We need to begin at 1 again. What determines where we begin, or where we draw, what we draw rather? Counter 2 determines what we draw. So we're going to have to reset counter 2 to be equal to 0, so that it can begin writing from the number 1 again, rather than just writing from the number 2. And this should just about do it. Let's go ahead and test our code. Let's go for 4 iterations, just like they have. There we go. Let's try a bigger number, 55 iterations. This will take a little while, but there we go. All the way up to 55. Let's try 35, 25. There we go. 1, 2, 3, 4, 5, 6, 7, blah, 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 blah. Again, if I didn't reset counter 2 to be equal to 0, it's just going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the side, or whatever it is. 10, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the side. By resetting counter 2 to 0, each row that needs to be drawn on will re-begin at 1 and draw the amount of digits that we are on in terms of rows. So, to repeat that, on row 1 we drew 1 digit. On row 2 we drew 2 digits. On row 3 we drew 3 digits. That means that each inner while loop, when we determine what we're going to draw, we need to run the code the amount of times that we are on in terms of rows. So how do we determine what row we're on? We determine what row we're on by using the counter 1. And counter 2 needs to determine what we're drawing, so we're drawing 3 times, and because we're checking if counter 2 is less than or equal to counter 1, it's going to run less than or equal amounts of times as there are rows. So on, for example, row 3, we're going to run 3 times, and each time it runs, we're going to write the value of counter 2 plus 1. So one last test, but let's go for, I don't know, 23 iterations. Cool, perfect, works. And this one we can go by 15 by 5. Works. 5 by 15, sorted. And there we go. So that's practical exercise 1 and 2 for practical 6 completed. So I hope you guys found this solutions video helpful, and yeah, I'll check you guys in the next one next time.